Now let us understand some miscellaneous functions of the numpy, such as determinant of a matrix and the rank of matrix. By using some very simple methods, we'll be able to find out this, such as determinant of a matrix or a rank of a matrix. We also are going to understand several other miscellaneous topics in numpy. Now, first of all, let us understand how we'll be able to, find out a determinant of a matrix. Now, the determinant will tell you the matrix has an inverse or not. If it is a non-zero, and it scales the space when the matrix is applied. You know that, what is determinant? If it has a perfect inverse. In NumPy, you can find out a determinant using np dot linealg dot det. Okay, since this is linalg dot det. This function will directly give you the determinant of a matrix if it is there. Now, just I'm going to use a matrix. That matrix is I just have created by using an array function. That in the array function I just have created a 2 into 2 array. Write down simply. The thing is, what I should do. I need to call the function linalg dot det, in which matrix should be passed as a parameter. And finally, the result will be passed to one variable which is called det. And when you print det, output will be minus 2.0. As simple as this, you will be able to identify the determinant. Now, we'll also be able to identify the rank of a matrix. What is rank? How many dimensions we do have that are linearly independent in a matrix? Now, if the matrix is a full rank, it means that all the columns are linearly independent. The rows and columns are linearly independent. That is what the rank of a matrix. But how will we be able to get the rank of a matrix? Simply, we just need to use linealg dot matrix underscore rank. Once again, linealg dot matrix underscore rank, to which you should be able to pass the matrix that has been created. Right, then this thing will actually, the result will be passed to one variable which is called rank. Then if you print the variable rank, the output will be equal to 2. The full rank for this 2 into 2 matrix. You'll be able to find out the rank of a matrix by using linalg dot matrix underscore rank, in which you need to pass a parameter of the matrix. Similarly, how will you be able to find out the inverse of a matrix? Simple. linalg dot inverse of a matrix. Okay, inv is a function. Inverse is a function to which you should pass the matrix. Right, then you will identify the inverse if it is there. Okay, but first of all, if you need to find out the determinant should not be equal to 0, right? Ensure the matrix has an inverse. If the matrix has an inverse, you'll be able to find out the inverse. For that, determinant should not be equal to 0. Else, matrix is singular, we cannot calculate the inverse. But the thing is simple. We'll be able to identify the inverse of the matrix by using the inverse function, linalg dot inv. This is going to compute the inverse of a matrix. Right, then we're going to understand how we'll be able to solve a linear equation using a numpy. First of all, we just need to understand, to solve a system of linear equations in numpy, you can use linalg dot solve. Then we will be able to solve the linear equation. Once again, linalg dot solve will be able to solve the linear equation. For an example, let us take ax is equal to b as a line equation. Now, A is the matrix of the coefficients, the matrix of coefficients, then x is the column of vectors, the unknown, b is the column of vectors of constants, right? Now, let's solve the system of the linear equation. For an example, there is 2x plus 3y is equal to 5. Example, another thing is 4x plus y is equal to 6. Here, A is equal to, what is A? Matrix of coefficient. What are the coefficients? 2, 3, 4, 1. And what is a B? B is 5 and 6, right? So, now, let us solve this by using numpy. Now, what we need to do is, we just need to, we are transferring the array 2, 3, 4, 1 into A. Okay, right, then we just are going to take constant. What are the constant? Constants are 5, 6. And then array has been passed to A, and constants have been, coefficients have been passed to A, coefficient array has been passed to A, constant array has been passed to B. And right then, what we need to do, to linalg dot solve, we should be able to pass A and B, the array of coefficients and the array of constants. Then it will be able to print the solution. Okay, the solution for the equation xy. Okay, right then. Then what we need to do is, the next thing is, we just are going to decompose a matrix by something called singular value decomposition. Okay, how singular value decomposition is going to be done? By using SVD in numpy. Now we know that in a singular value decomposition, A is equal to U sigma V transpose, right? A is the original matrix, use the orthogonal matrix, use containing the left singular vectors. Sigma is the diagonal matrix containing the singular values, square roots of the eigenvalues, the eigenvalues, right? Eigenvalues and eigenvectors. V transpose is the transpose of the orthogonal matrix V. But see, we'll be able to simply calculate single value decomposition, okay, by using the matrix decomposition by SVD, very simply by using numpy. How do we do it? Let me show you. Let's take an example. Let's decompose a matrix using SVD. A is equal to 3, 4, 2, 5. That is 3, 2, 3, 3, 4, 2, 5, 3, 2, 4, 5. Okay, the columns. And then what we just need to do is, only the thing is, we need to pass A, okay, to the function np dot LINALG dot SVD. Then only the thing is np dot LINALG dot SVD. If you pass A, it will decompose the array by using SVD. Okay, then the decomposition returns three matrices: U, the left single vectors; sigma, singular values, which will be the 1D array as you already knew; VT, that is singular right singular vectors which are transposed. VT. Okay, V power T. Now, as we discussed, this is how we will be able to calculate this is how we'll be able to decomposing by using SVD. And the next thing is, we'll also be able to calculate eigenvalues and eigenvectors. For that, what you need to do is, you just need to say EIG dot A, EIG of A. When you say EIG of A, simple, NP dot LINALG dot EIG of A, where A is a matrix, of which you just want to find out eigenvalues and eigenvectors. And then eigenvalues will be passed to eigenvalues variable, eigenvectors will be passed to eigenvectors variable. The values written by the eigenvalues in the eigenvalues of the matrix A, eigenvectors will be the values which is written by the eigenvectors in the given matrix A. This is how you'll also be able to calculate eigenvalues and eigenvectors. Thank you.